Greetings, folks. This lab is going to give you the opportunity to play around with electric circuits. You're going to have a board that's going to have 3 light bulbs in it. We're going to treat those light bulbs as though they were resistors. We're going to manipulate the light bulbs to see if we can't figure out how they're wired. There are also 3 switches in this system. 2 switches in the system, which should make things kind of exciting. The first thing that you need to do when you run into a situation like this, if you were in the lab, the first thing you would do is try to figure out how the resistors are related to one another, how they're connected to one another. So for instance, are they in series? Is one right next to the other, which is right next to the other? In this kind of a situation, you have current being common to all the elements, which means that if you were to go ahead and disconnect, like unscrew one of these bulbs, it would break the circuit and you would no longer have current going through any of them, so they'd all go out. Is the combination in parallel? So a parallel combination looks like this. In a situation like this, if you were to unscrew one of the bulbs, it would go out, but the other bulbs wouldn't go out because they would still be hooked across the power supply. And so the provision of current, the provision of electrical potential, which produces the current, wouldn't be disrupted. So by unscrewing light bulbs, you can tell how the entities are related to one another. Another possibility, you could have a parallel combination that is itself in series with a light bulb. So in this case, if you unscrewed that light bulb, this light bulb wouldn't go out and this one wouldn't go out, but this one would. If you unscrewed this light bulb, they'd all go out. So the moral of the story is, if you unscrew a light bulb that's in series with stuff, the light bulb will go out and all the stuff will go out. If you unscrew a light bulb that's in parallel with stuff, the light bulb will go out, but the stuff won't. Now, if you add in switches, things get, as I said, even more exciting. But for right now, let's just deal with the light bulbs. This is the example. I'm actually going to show you 2 examples. Here is our circuit box. Here are our 3 light bulbs. There are also switches down here. The problem that you run into, or I ran into when I started this up, was I go ahead and plug that in, everything gets washed out. So what I'm going to do is I'm going to use this green filter. I'm going to put it across like so. And if I do, you can see where the light bulbs are. I'm going to go ahead and I'm going to unscrew the light bulb on this side and watch to see what happens. It goes out, but the other 2 don't. Which means that light bulb apparently is in parallel with this other stuff. You don't know how the other stuff is related to themselves. But you know, if nothing else, this one light bulb is in parallel with all that other stuff. If I go ahead and unscrew this light bulb, it's hot. Again, the other 2 don't go out. Apparently, this light bulb is in parallel with that stuff. Unscrew this guy. The other 2 don't go out. Apparently, it's in parallel with the other stuff. So, bottom line, what I'm looking at in this particular case is this circuit right here. If you were starting from scratch, you would simply keep track of what you were doing. Okay, you would just had the first one you did, there it is. You would realize, okay, it's going to be in parallel with some stuff. So you'd go ahead and you put in a parallel branch, and then you'd wait to see what the other stuff was. And the other stuff could have been a series combination. You weren't sure. You had to test to see. What you finally concluded in this case was that all of the elements were in parallel with all the other elements. So you were looking at something that looked like this. Once you have the general form for the way that the resistors are connected to one another, then you have to deal with the switches. Now, switches can do one of two things. A switch that says that it's off means that it's open. So normally, if you turn a switch off, you expect everything to go out. And the reason why is that under normal circumstances, switches are in series with elements. So you turn it off, it cuts the current, it cuts the power, everything goes off. So if I go ahead and I flip the switch to the off position and a particular resistor goes off, I know that that switch is in series with that resistor. So if I flipped in this particular case, a particular switch and a particular resistor went off, say this one, I would know that I needed to stick a switch in here. And it would have to be in series with this resistor. Now, what's tricky is that a switch that is on means the switch has been thrown, which means now there is a connection with the resistor, which means current does flow. You would expect, therefore, that when you throw a switch and it's on, you would get current through the light bulb. But there is a situation in which that wouldn't happen. So what about this circumstance? What about putting a switch across a light bulb? Now when the switch is off, all the current's going to flow through the light bulb. But when the switch is on, the current is going to circumvent the light bulb. And a tiny trickle is going to go through the light bulb, so the light bulb will be just barely lit up. But for all intents and purposes, it will look like the light bulb turned off. So if you throw a switch and a light bulb goes off, you actually have to look to see whether the switch is on or off. If the switch is off, it means you have this kind of situation. Okay? It's off, it's in series, light bulb goes off. If it's on, though, it means you have this kind of situation. You have dropped the switch so that it's on. Current is circumventing the light bulb, and the light bulb appears to be going off, or to be off. So you have to be careful with switches. In this particular example, let's see what we have. So right now, both of the switches are on, and if I plug in, everything is lit up. So we still have our parallel combination. We figured that out. I'm going to go ahead and flip one of the switches. Doesn't matter which one. I'm just going to flip it. Everything goes out, which means apparently when this thing goes to off, everything goes out, which means it's in series with everything. So I would put a switch there. Get rid of all this stuff. So far, this is what my circuit's going to look like. I've got a parallel combination, and I just stuck a switch here, and when I put it off, everything goes out. Okay, so now I'm going to put it back on again. So I have everything lit up, and I'm going to flip the other switch. So I'm putting the other switch off. And when I turn it off, one of the other bulbs goes out. So again, it's off. That means it must be in series with this other bulb. So, in series with one of the other bulbs, I put a switch. And there is my circuit. 3 light bulbs and 2 switches. The second example I wanted to show you is this. So I'm going to go ahead, once again, I'm going to plug it in. When you're trying to figure out in general what the circuit looks like, you want to set it up so that all of the bulbs are lit. So you need to flip the switches in whatever way you need to do that to get them so that they all light up. So right now, it's a little bit hard to see, even with this up. But these 2 here and here, they're actually lit up, but there's just a trickle of current flowing through them. So they're very dim. And then you have this one here. So I'm going to go ahead and I'm going to unscrew this guy, the really bright guy, and just see what happens. So if I do that, oops, just going the wrong way. Everything goes out. So apparently it's in series with whatever the other stuff is. I go ahead and I put my resistor in. There he is. And he's going to be in series with all this other stuff. So the question is, what is all the other stuff? So I'm going to go ahead and rescrew this in, and bring this up, and I'm going to unscrew one of these 2 that's in which I've got a trickle. And when I do that, the other one in which I have the trickle doesn't go out. Which means evidently they're not in series. If they were in series, if I unscrewed the one, the other one would go out. And just to check to make sure, I'm going to unscrew the other one, and its partner doesn't go out. So evidently these 2 guys that I just have a trickle of charge flowing through, they're in parallel. So my combination is going to look like this. Now it's time to figure out what the switches are doing. Okay, so to get everybody lit up, I have one switch on and the other switch is on. So both switches are on. So I am just going to go ahead and flip one of the switches to off and just see what happens. Everything goes off. I'm going to go ahead and switch the other one to off and see what happens. And one of the parallels goes out and the other one doesn't. The temptation is to say, okay, so I've got a switch here and I have a switch here. Now, you want to check to make sure that that really is going to work. So all of the various flipping combinations that I can do work out, and this apparently is what the circuit is.